For decades, humanity's dream of exploring the cosmos has been held back by one stubborn obstacle: cost. Traditional rockets are marvels of engineering, but they're built for a single use, launched once, then discarded forever. Each mission leaves behind a trail of spent boosters and burnout stages, piling up in graveyards and scrap yards, a stark reminder of how much we throw away in our quest for the stars. SpaceX's Starship is designed to break this cycle, aiming to create a fully reusable highway to space. The vision is bold: a spacecraft that can launch, land, and fly again, dramatically lowering the cost of access to orbit and beyond. At the heart of this ambition lies a revolutionary heat shield, a technological leap that could make or break the dream of reusability. Re-entry is a brutal ordeal. As Starship plunges back to Earth, it faces temperatures soaring to 1,400 degrees Celsius, hot enough to melt steel. The friction with the atmosphere creates a blazing plasma sheath, threatening to incinerate anything unprotected. Without a robust thermal barrier, the spacecraft would be destroyed in seconds, its structure and systems overwhelmed by the intense heat. The heat shield's job is to absorb and dissipate this energy, protecting not just the craft, but also its precious cargo and crew. Every tile must perform flawlessly, flight after flight. Each test flight, whether a spectacular success or a fiery failure, has revealed new weaknesses and inspired critical improvements. Engineers pore over data, learning from every scorch mark and crack. The evolution from V2 to V3, as seen in Ship 39, is a direct response to these hard-won lessons, with each new version tougher and more resilient than the last. For Starship to become truly reusable, its heat shield must not only survive the inferno of re-entry, but do so again and again, requiring only minimal repairs between flights, a challenge never before mastered at this scale. Mastering this technology is the final step before humanity can safely return from the stars, opening the door to a new era of exploration and possibility. The V2 Starship heat shield faced harsh realities during flight. Tiles cracked, chipped, or broke away under intense vibration and heat, exposing the steel beneath to dangerous hotspots. The attachment system was unreliable, and experiments with transpiration cooling added complexity and risk of leaks. Gaps between the 18,000 hexagonal tiles shifted during flight, letting superheated plasma threaten the structure. Oxidation further weakened the steel frame. These weren't minor issues, they threatened the entire concept of reusability. Each test flight exposed flaws, making it clear a radical redesign was needed. The V2 shield simply wasn't ready for operational missions. SpaceX had to return to the drawing board and rethink thermal protection from the ground up. Starship V3, led by Ship 39, is SpaceX's answer to V2's failures. The new heat shield tiles are stronger, more uniform, and less prone to cracking. A new mounting system, using advanced adhesives and a floating stud design, keeps tiles secure through launch and re-entry. Tighter, nearly seamless gaps are filled with heat-resistant material, blocking plasma intrusion. Lighter insulation replaces some tiles on the leeward side, saving weight without sacrificing protection. V3 abandons complex active cooling for a simpler passive system. The result? A shield that's more reliable, easier to maintain, and ready for rapid reuse. Every improvement is aimed at making Starship as robust as an airliner. Ship 39's shield isn't just an upgrade, it's a complete reimagining of spacecraft protection. This is the foundation for a vehicle destined for other worlds. Perfecting Starship's heat shield is about more than just surviving the intense heat and forces of re-entry. It's about making spaceflight as routine and reliable as catching a commercial flight on Earth. For Starship to truly revolutionize access to space, it must be able to fly, land, and relaunch within days, not months or years, enabling rapid turnaround and frequent missions. A durable, resilient shield is the linchpin of this vision. If it requires constant, time-consuming repairs, the dream of true reusability slips away. SpaceX's ambitions stretch far beyond Earth orbit. Moon bases, Mars cities, and a future where humanity is multiplanetary all depend on this technology working flawlessly. The V3 shield is engineered for repeated entries, both at Earth and Mars, with minimal maintenance between flights, pushing the boundaries of what's possible in spacecraft design. Lowering launch costs through reusability could open space to entirely new industries, scientific research, and exploration opportunities that were once out of reach. But if the shield fails, the entire economic model collapses. Missions are delayed, costs skyrocket, and the promise of affordable space access fades. The space shuttle's fragile tiles were a cautionary tale, requiring extensive maintenance after every flight. Starship must overcome these limitations to succeed. SpaceX's goal is a shield so robust and reliable that it needs only a quick visual check between flights, dramatically reducing turnaround time. Achieving this will transform Starship from an experimental prototype into a true workhorse for space exploration and transportation. The V3 heat shield represents SpaceX's boldest step yet toward making space travel as safe, accessible, and routine as air travel, unlocking a new era for humanity among the stars. Starship's heat shield is a massive puzzle. 18,000 unique hexagonal tiles, each tailored for its spot. Managing this complexity required SpaceX to pioneer new manufacturing methods. At the Texas Star Factory, automated lines produce hundreds of tiles daily, streamlining shapes and processes for efficiency. Robotic arms now install tiles with precision, ensuring tight, uniform gaps. The V3 design's uniformity and improved mounting make production and installation faster and more reliable. After flight, every tile must be inspected for damage, a daunting task. SpaceX is developing automated systems to scan and identify issues quickly. The ultimate goal, robots that can replace damaged tiles right on the launch pad. Solving this puzzle isn't just about building the shield, it's about mastering its entire life cycle. This is the path to rapid, reliable turnaround for every Starship mission. Ship 39 is the proving ground for the V3 heat shield. Before flight, it faces cryogenic tests, tanks filled with super-cold liquid nitrogen, to see how tiles and adhesives handle extreme contraction. Any weakness must be found on the ground, not in flight. Next, static fire tests shake the ship with engine vibrations, testing the shield's mechanical resilience. Engineers watch for any tiles shaken loose, a problem in earlier versions. Only after passing these trials will Ship 39 attempt an orbital flight. This flight will test the shield against launch, space, and the searing heat of re-entry. Thousands of sensors and cameras will capture every detail. A successful re-entry with the shield intact would be a breakthrough for SpaceX. It would prove Starship is on the verge of true, rapid reusability. The V3 heat shield is more than just an upgrade, it's a cornerstone for the future of space travel, representing a leap in both technology and ambition. This shield is designed to withstand the most extreme conditions, protecting not only the spacecraft but also the dreams of those who dare to reach for the stars. A truly reusable Starship could make space as accessible as the skies above us, transforming not just exploration but also industry, science, and even the way we think about our place in the universe. Imagine a world where launching into orbit is as routine as boarding a plane. If SpaceX can manage, maintain, and reuse 18,000 tiles efficiently, it sets a new standard for the entire industry. This level of reliability and reusability could dramatically lower costs and open the door for more frequent missions, making space accessible to more people and organizations than ever before. This technology could enable not just asteroid mining but also the construction of orbital habitats and the establishment of permanent settlements on the Moon and Mars. It's the foundation for a future where humanity is a multiplanetary species, thriving beyond the cradle of Earth. Ship 39's shield stands as a beacon for all of humanity's space ambitions, a symbol of our determination to push boundaries and explore the unknown. Every mission it undertakes brings us closer to a future where space is within everyone's reach. Even if V3 succeeds, SpaceX will keep refining, pushing towards zero maintenance, ever better shields. The pursuit of perfection never ends, and each improvement brings us closer to making spaceflight as safe and routine as air travel. Each flight brings new data, fueling the next wave of innovation. Every test, every launch, and every landing is a step forward, teaching us more about what it takes to survive and thrive beyond Earth. Like the great ships that once crossed uncharted oceans, Starship's shield is the hull for a new era of exploration. It's the vessel that will carry us across the vastness of space, opening new frontiers for discovery and adventure. It's the bridge to other worlds, built one black tile at a time. Each tile is a testament to human ingenuity and the relentless pursuit of progress. The future of humanity's journey beyond Earth is being forged today, in the hands of those who dare to dream bigger and reach farther than ever before.